Hi everyone, thanks for joining me. I know that we're all keen to improve the quality of the performance testing work that we do, and I thought we could take a proven practice from the software development world and apply it to our performance testing world. It's only pretty recently that a lot of us have started using version control for our scripts. If you've already done that, I'm going to be telling you what your next step should be. And if you follow my advice, you will have advanced to software development practices that were common in the late 90s. Software-based version control has been around since the 70s, and for a software developer, use of version control has been taken as a given since at least the 90s. But in the performance testing world, it's only in the last couple of years that support for version control has been built into our tools. So we're very much late adopters when it comes to version control. And when the dev team finds out that you're not version controlling your scripts, they kind of look at you like you're a caveman or something. But at least with version control, we're finally catching up. So what other common standard development practices are we not doing? Let me tell you about static code analysis. Static code analysis has been around since the late 70s, and it finds bugs in your program by reading and analyzing the source code rather than compiling and running the software. Some kind of static analysis is built into most modern development environments, and dev teams add static analysis tools to their CI pipelines. Examples of things you might do with a static analysis tool are maybe picking up unsafe use of memory in a C program, or maybe just simple stuff like enforcing stylistic preferences in the source code, or maybe you're going to pick up security defects. In fact, there's a static analysis tool for web application security defects that is sold by Micro Focus, and it's available either as a standalone product or as Fortify on demand. And it looks for web application security defects like SQL injection or directory traversal. Simple things that you can pick up from the source code. Sometimes my clients will say that they don't need a static analysis tool because they already do code reviews. And I say, that's great. You're halfway there. But let's take the list of things you look for in manual code reviews and see how much of that we can automate. Wouldn't it be nice to have a computer do the boring stuff and save your time for the high-value activities? The number of performance testers that don't bother to check that the server is giving them the correct response under load astounds me. Wouldn't it be nice if we could make sure that, at a minimum, performance testers are writing scripts with checks in them? And there's a whole bunch of other scripting standards that are definitely machine checkable. So who are the people who might benefit from a static analysis tool? Imagine that you're the manager of testing services at a large bank. So you're responsible for all sorts of testing at the bank, but because performance testing has been so expensive, it's been outsourced to a low-cost offshore testing services partner. Now, your level of confidence in the quality of the work might be kind of low. There's not a lot you can do about it. The decision to engage them has been out of your hands. But you want to ensure that they're doing the best job possible. You want to keep your vendor, who you're paying millions of dollars a year to, you want to keep them honest. But part of your challenge is that you don't have that many staff, and you certainly don't have budget for more staff yourself. And in order to keep a testing services partner honest and keep the quality of their work high, there are certain governance tasks that you kind of have to do. If you had a static analysis tool, you might be able to monitor the scripts that are added to the Performance Center repository. And maybe you want to plot the bad scripts on a dashboard. Maybe you want to alert when the scripts are checked in and they're not up to quality standards. But it gives you a window, some visibility into the sort of work that is being done for you. Maybe if you're particularly cunning and you got in early enough, you can ensure that there's some fine print in the contract with the testing services partner that says all scripts should meet internal quality standards. And now you have a tool that is a way to measure their compliance with your internal quality standards. And when they don't, it gives you some leverage to encourage them to improve the quality of the work that they're doing. On the other side of the coin, imagine that you're the practice manager at the outsourcing firm that got the contract with the bank. You've got an offshore team of mostly grads and fairly inexperienced staff, but you know that if they do a really bad job, you'll lose the contract with the bank. Your challenge is, how do you uplift the quality of the work that your team is doing without cloning yourself and individually hovering over every single member of the team, because you certainly don't have time to do that. A static analysis tool would help your team boost the quality of the scripts that they deliver. It would allow you to keep some form of control over the quality of the scripts that your team's writing, to encourage them to do a better job, and to hopefully not end up disappointing your client despite all of the constraints in terms of people power that you have. A static code analysis tool for your load testing scripts is useful whether you're new as a performance tester or you're really experienced. Either way, it's a safety net. For a beginner, it helps catch all of those really common mistakes that all beginners make. And for an experienced performance tester, well, everyone makes mistakes occasionally, and it's nice to have a tool pick them up when you do make them. As a senior person, it's also nice knowing that the rest of the team are meeting quality standards when they check their scripts in. If you're already using version control for your load testing scripts, the next step in maturity for your team is to add a static analysis component. You can use a Git pre-commit hook to automatically run your static analysis tool before anyone checks in code. If there are problems with the script, well, it prevents you from checking them in. And if there's not, well, you know that the script complies with your internal standards. You can even use this to improve the quality of a repository full of existing scripts. Every time someone modifies a script and goes to check in their change, well, the entire script must meet the quality standards that are defined by the static analysis tool. So you'll gradually, one by one, as each script is touched, improve the quality of all of the scripts in the performance testing script repository. I hope I've managed to convey to you how static analysis can help improve the quality of the scripts that your performance testing team is writing. I hope you see how this is the next step in maturity for performance testing, and maybe feel just a tiny bit embarrassed that we're still 20 years behind the software development teams that we love to find defects for. Thanks for listening, and good luck with your performance testing.